25 mark second order differential equation for further maths A level. Now, I was tagged in this twice on TikTok and someone sent it on the Lungang Reddit. If you guys want to go to the Lungang Reddit to submit questions, the link is in the description. And I had already agreed to this before I realized probably how difficult it was going to be. And what's funny is if you go to the video on TikTok, which I'll put in the description as well, a lot of people in the comments were saying this is super easy. And when you go in the comments thread, these students are actually getting everything wrong. So it's not good for them. They should probably watch this video as well. So I'm going to attempt to do this for 25 marks. So how do we go about solving any second order differential equation? We need to look at the auxiliary equation, solve that first, okay? Usually you guys know I write downwards, right? I'm going to have to write left to right because I need to save some space. So let's look at our auxiliary equation. So we have lambda squared 2 lambda 5 equals 0. Lambda squared 2 lambda 5 is 0. Now we need to solve that. So I'm going to do that by completing the square. I wouldn't use the quadratic formula here just because the coefficient here is even. So we have lambda plus 1, halving that coefficient, squared, minus that number squared, which is minus 1. Then we add 5 is 0. So that gives me plus 4. So when I move the 4 over and square root that, I get plus or minus 2i. And then you get lambda is minus 1 plus or minus 2i. Okay, so what is my solution without the particular integral so far? So I'm going to get x is a linear combination of e with the two lambda solutions as the power. So you get minus 1 plus 2i t and b e minus 1 minus 2i t. Now from here, we can split this because we know complex solutions is a linear combination of sine and cos with the angle being 2. But with this minus 1t, minus 1t, we can factorize that out. I always show this in the exam. So we have x equals e to the minus t. We would have ae to the 2it plus be to the minus 2it. And from here, you don't need to show this bit. You don't need to use e to the I theta is cos plus I sine. You don't need to use that. We can go straight from here into our P and Q linear combination of sine and cos. Okay. So far I have x equals e to the minus t. P, they use, okay, I'll do sine first then. P sine 2t, whoops, plus q cos 2t. Okay. And this is the easy bit of the question. All right. Now we need our particular integral. Now the particular integral is going to be based on this. Okay. And this is where the kids in the TikTok section did not understand what they were doing. The particular integral, you should notice, these two have the exact same form. Okay. If you were to expand this, you would have p e to the minus t sine 2t and q e to the minus t cos 2t. If you expand this, you get the exact same form. So your particular integral cannot look like this. All right? What we need to do is we need to put a t at the front. Okay? And on top of that, you can't just put a t in front of this, yeah, to introduce a new function. You need to consider the fact that these are two separate functions. So actually, we're going to have to think about this as an expanded particular integral. Okay? So my particular integral is going to be x is, now it's the expanded form, and I need to put t. So think about expanding this, but with a t. So it's not p, it's going to be pt, but I'm going to use a. Okay? Actually, no, I've used a and b, let's use c. So it's going to be c, t, e minus t, sine 2t, and d, t, e minus t cos 2t. Okay, so, I mean, you could have expanded it, but because we have to differentiate this, I'm expanding it. All right, so we do need to expand this because with our particular integral, we're going to get x dot, x double dot. We're going to sub into here, compare coefficients. Hopefully the t's will cancel out, and we can find what d and c, we could just find d and c. So let's differentiate this, x dot. Now the way I'm going to do this is I'm going to treat this as two separate functions, like this. We're going to do the product rule, but the way we differentiate this is we have to do the product rule again. All right, so let's go about it. So we differentiate the first term times the second term plus differentiate the second term. Now that's going to bring out negatives, so what I'm going to do is I'm just going to write the first term first. Okay? So differentiate the first term times the second. The differentiated second term, I'm just going to write it here. All right, so to do that, we differentiate this, which is minus e to the minus t, times the first, sine 2t, plus differentiate the second term, which is 2 cos 2t, times the first term. So it's just, 2e to the minus t cos 2t. Just to double check my work. Differentiate the first term times the second, differentiate the second term times the first. Okay, cool. Then we have to do it with this as well. So, plus differentiate the first term times the second plus differentiate the second times the first. I'll write dt first. Okay, differentiating this. Wait. Differentiate times. Okay, so differentiate. So that'll be minus e to the minus t cos 2t. Then cos goes to minus 2 sine 2t with the e, so you get minus 2 e minus t sine 2t, right? Now this looks disgraceful because we're going to have to differentiate that again. So what I'm going to do is I'm going to collect the sines and causes. All right, so I'm going to read, and I'm going to read the sine 2t coefficients. I say sine 2t, but it's e to the minus t as well. Sine 2t, so I have c. So I'm actually going to write e to the minus t sine 2t times c. Going along, this would give me a e to the minus t sine 2t. So I'm going to expand it basically. I'll get ct times minus 1, so minus ct. Then there's no other signs. That's not a sign. The next one would be this one. So dt times minus 2, so minus 2 dt. Plus e to the minus t cos 2t, we're going to do the exact same thing. So reading along, we have this times this, that's 2ct plus d minus dt. Okay, if you wanted to, you could have factorized the t out, but I'm just not going to do that. All right, let's differentiate that again. The handy thing here is we've already differentiated these, so I can just copy and paste, right? So it's going to be even longer, right? X double dot is differentiate the first times the second. I'm actually going to think of it the other way around. I want to write this one first. So differentiate this. That would get minus c minus 2d. Minus c minus 2d. Minus c minus 2d times this. Differentiate times, differentiate times. So I'm going to write this first times the differential of this. Which, when did I do that? That was this. right. This is just the differential of this. So I'm going to do plus. Again, I'm doing it the other way around, right? Differentiate this times this. So that'll be 2c minus d times e to the minus t cos 2t plus. Differentiate this times this. I'm going to write that first. Times the differential of this, which was this. Okay, now, what we need to do is we need to take this, which I don't even know, do I want to clean this up? There's too much to expand. I'm not expanding that. That needs to be subbed into here. Then I need to add 2 lots of this, plus 5 lots of this, and I need to equate the coefficients. Now, there's no way I'm writing that on one line. So what I'm going to do is I'm going to be tactical here. I'm going to observe the coefficients of cos first, okay? So what we're going to do is we're going to work backwards. We're going to find the coefficients of cos first, all right? Now, going along, this is sine, so I don't need to worry about that. This would multiply in, which would find me that coefficient of cos. I would have this times 2. So I'm going to get 2c minus ct minus 2 dt. That times this gives me cos. I have another cos here, plus 2c minus d. And then I get another cos here, minus this. I'll just write the whole thing. It equals 4. Can't lie, I've got a headache. I'm hoping the t's need to cancel here. So I got 2c minus 2ct minus 4 dt plus 2c minus d minus 2ct minus d plus dt is 4. Minus 2ct minus 2ct. I was hoping that they would have ended up cancelling. Because the dt's, 4dt, minus 4dt. Oh wait, I didn't times them by the coefficients. 2x. That's why they don't cancel. So wait, the coefficient from this was that. Oh no, wait. X double dot. Where's those coefficients that I wrote down? I swear that was this. I have this times 2, yeah. Then I have, oh, I'm being an absolute fool. This here is just x double dot. I didn't even do the other ones. That is just this one. I need to do 2x dot. So I need to do 2 lots of these. That coefficient's this one. So plus 2 lots of 2ct plus d minus dt plus 5x. 5 lots of this one. That's just 5 dt. 5 dt. All right, fingers crossed. I just expanded this and now I need to do it again. Okay. 2c minus 2ct minus 4 dt plus 2c minus d minus 2ct minus d plus dt plus 4ct plus 2d minus 2 dt plus 5 dt is 4. Minus 2 CT, minus 2 CT is minus 4 CT, plus 4 CT. Beautiful. That's what I was hoping for. Minus 4 dt plus dt is minus 3 dt. Minus 2 dt is minus 5 dt, which when you add 5 dt, these all just cancel. 2c plus 2c is 4c. Minus d is minus 2d plus 2d. They all cancel. Yo! So we get 4c. 4c is 4, so c is 1. C is 1. I want to write more working here. Let me just write here. Okay. Just double check a different pen. All right. Switching it up. Let's do the coefficients of sine. Okay. So these were the cos coefficients. Now let's look at the sine coefficients. We're doing the same thing, right? So with x double dot, we just have one of those. So going across, I have minus c minus 2d sine. Then I get this times minus 1. Minus 1 of that. So minus c minus ct minus 2 dt sine. That, nothing. This times that. So minus 2 lots of this. Minus 2 lots of 2ct plus d minus dt. Then for the x dot, we just need 2. So for this, we just need 2. There's the sine 2t. We just need 2 lots of that. So we need 2 lots of c minus ct minus 2 dt. And then we need 5 lots of the OG. 5 lots of that. That's just 5 CT. And that also equals 4, right? Because that's 4e to the whatever. Right, let's expand. Minus c minus 2d minus c plus ct plus 2 dt minus 4 ct minus 4 ct minus 2d plus 2 dt plus 2c minus 2ct minus 4 dt plus 5 ct is 4. ct minus 4 ct is minus 3 ct. Minus 3 ct minus 2 ct is minus 5 ct plus 5 ct goes. 2 dt plus 2 dt is 4 dt minus 4 dt. Beautiful. Minus c plus 2c. Minus c is any other c? Oh wait, no, minus c is, they just cancel as well. I was hoping that that would happen the same thing, like the d's all cancelled out, right? Minus 2d minus 2d is minus 4d equals 4d is minus 1. Rah, so my solution is this plus this with my d's and c's subbed in, which is c is 1, so plus 1 lots of t e to the minus t sine 2t, and d is minus 1, so minus t e to the minus t cos 2t. Now, what we're going to have to do with this solution is we need to sub in t is 0 and 1, differentiate it, sub in t is 0 and 2, and that's then going to let us work out what p and q are. Now, I think the best way to differentiate, because subbing in is not a problem, right? It's differentiating and then subbing in. I think the best way is to collect the sines and causes. But what I'm thinking is here, I want to reuse these because we're going to have to differentiate e to the minus t again. I want to save, I'm going to rub something out, but I just want to save where the e's and the sines and the causes differentiate. That's this one. Do I ever use that again? I don't. This one's the differential of the e to the minus t sine. And this one's the e to the minus t cos. Okay? So I'm going to get rid of all of this. And then we'll see. I'm very confident that I don't need this information anymore. Okay? So, let's collect. X is, for the sines, it will be p plus t e to the minus t sine 2t, and q minus t e to the minus t cos 2t. Is it looking good in terms of my solution? I'm trying to work out, it looks like p is 2, q is 1. Let's sub in this first. So that's t is 0, 1. So when t is 0, when t is 0, x is 1. So we get 1 is 0, we'll have p. Oh, sine of 0 is just 0. 1, 1, 0, so q. Oh, okay, that's easy. So q is 1. Ah, that's proved. Okay, cool. So, that's easy to show you lot. I'm not going to write any more there. I'm going to just get rid of that and just go about my business of finding out what p is now. Okay, maybe I could write it here. So what was it? T is 0. I didn't realize there was going to be such little working. Right, so we have to differentiate this x dot. Differentiate the first term. That goes to 1. Wait, p is a number, so t goes to 1. So we differentiate that is just 1 times the second term plus differentiate the second term, which is this. Times the first term. Differentiate first times second. Differentiate the second times first. Now we have to do the same thing here. Differentiate the first is minus 1 times the second plus differentiate the second. At this point, this is just bullying. This is mathematical bullying. Now we don't need any of this. Okay. Very satisfying. When t is 0, x dot is 2. So we're left with 2 is sine of 2t is just, sine of 0 is just 0 plus 0. Cos of 0 is 1, 1, 2 times 0p. 1, 1, minus 1 plus 1, 1, minus 1, 0. 2 is 2p minus 1 minus 1 minus 2. 2p is 4. I think this is working. So there we go. And now I have the absolute privilege of writing down my final solution. Therefore, which this is always the best bit, x is, they write the, we can also factorize out the e to the minus t. So first I'll write the subbed-in things. So 2 plus t, e to the minus t, sine 2t, plus 1 minus t, e to the minus t, cos 2t. Which gives us, when we factorize out the e to the minus t, and they want the sine one written first, which I have, 2 plus t sine 2t plus 1 minus t cos 2t. Let's just look at this for a while, because this is kind of nuts. But that is it. My knees are weak, arms sweaty, vomit on the sweater, mom's spaghetti. Managed to get in the end 25 marks. Guys, I'd really appreciate if you could share this video with your other mates who might have been talking about this question. If you learned something today, hit that like button, subscribe for more maths content like this. And yeah, head to my Lungang Reddit page and my TikTok and all that stuff to submit questions and all that. I need to go to sleep because my brain is killing me right now. Good night. Thank you very much. Nice.